Hey Scott, sorry the videos and the help on Khan Academy weren't helping you as much as would have been nice. Let me hit up law of sines, general triangle, word problems, and special right triangles. Okay, so let's do special right triangles first, just because it's first. So there are really only two special right triangles, and we did cover them in class. Writing tablet, which of course is missing its pen. There it is. Okay. Right, so there's only two special right triangles that we talk about. I'm going to talk about this kind, which is a 30, 60, 90, and then I'll talk about the other one really quickly too. When we get to it, we'll just work on this one for right now. Okay, so in this problem, we see that we have a 30, 60, 90, and we're noticing what the sides are, right? We have x. Okay, so let's actually talk about where these triangles come from. Okay, I don't know why it wasn't working the first time. Okay, let's just erase everything. Okay. Right, this is an equilateral triangle. All the sides are the exact same length, and all these angles are the exact same angle. So they're all 60 degrees, 60 degrees, 60 degrees. That adds up to 180. If we cut this triangle exactly in half, we get a 90-degree triangle over here and a 90-degree triangle over here. Remember, we cut it exactly in half. So if this was, let's say, 2 and 2, then these on the bottom would have to be 1 because we cut the bottom exactly in half. But we can figure out this other side right here without too much difficulty. It's a right triangle, so we know a squared plus b squared equals c squared. Well, in this case, we know 1. We don't know this side. So 1 squared plus b squared equals, and in this case the hypotenuse is 2. 2 squared. Simplifying this, we have 1 squared becomes 1 plus b squared. 2 squared is 4. So b squared must be 3. Simplifying it further, b must be the square root of 3. Okay, so we know that this is the square root of 3. Now, if instead of saying this was 2, we said this was 2a, this was 2a, then that would make this a, or 1a, and that would make this a root 3. So if this was 10, this would be 5. This would be 5 square root 3. If this was 80, this would be 40. And then this height right here would be 40 square root 3. So coming back to our problem right here, right? 6 root 2, that's across from the 30, right? That's our short side, the long side, the hypotenuse cut in half, right? So this is this right here. Let's change it to red. This side right here is 6 root 2. That's this side length right here, which means this would be 12 root 2. Well, what about this side? Well, normally what we do is we take this side, right, which is normally just a, and we multiply it by the square root of 3. So that's what we're going to do. We're going to do the 6 times the square root of 2 times the square root of 3. Well, that gives me 6 square root 6. Right? This is the side length right here in a 30, 60, 90 triangle. And you'll see, looking over here, that's one of my options. So we're going to select that one and go to the next one. Okay, this is another 30, 60, 90. So it's going to be basically the same as it was before. One we know the medium side, right? This is the short side. All right, so coming back over here to our triangle, let's make a new page. No. Let's zoom so it takes up the whole thing. Okay. Right, so taking a look at your standard 30, 60, 90. Right, here's 30. Oh, no, that's 60, 60, and 30, right? 30, 60, 90. Well, we know our 30's here. Our hypotenuse is unknown, and the medium side is 6. Well, our basic one says that this is 2a, this is 1a, and this is a root 3. So 6 equals a root 3. How would we turn the 6 into 2a? Well, we need to divide it by square root 3, right, to get rid of the square root 3. So that's gone. And then we need to times it by 2 to make it be 2a. So we get 12 over root 3 equals 2a. This be ugly, right? How are we going to simplify this, right? None of the answers look like this right here. Well, if I multiply the bottom and the top by the square root of 3, the square root of 3 times the square root of 3 is 3. So we get 3, and on the top we have 12 root 3. Hey, I can cancel out this 3, and I'm part of the 12, right? 12 divided by 3 is 4. I get 4 square root 3. And again, all I'm doing is I'm trying to change a root 3 into 2a. And the only way I know how to do that is to divide a root 3 by root 3 to just get a all by itself. And then times it by 2. And then I'll have 2a. This one, it got a little wonky because we had to simplify when we had a radical in the bottom of a fraction. So if you ever have a fraction with a radical on the bottom, right, like let's say we have a over the square root of b, you can always multiply that by the radical that's on the bottom, right? The square root of b times the square root of b, well, that's just b. And then the top would be the a square root of b. Right? This is a way you can always get the radical out of the bottom. And then after you've got it out of the bottom, always check to see if maybe there's a way to simplify, right? 12, we can divide that by 3, so we were able to simplify this one to 4 root 3.